Rational expressions, addition and subtraction, part 2. Let's review the steps for adding and subtracting rational expressions. Step 1 is to find the least common denominator. Step 2, write equivalent fractions with the LCD from step 1. Step 3, keep the LCD and put it over in the answer. Step 4, combine the numerators. And step 5, simplify if possible, and remember to factor first. Let's recall just adding regular fractions. Our first step is to find the common denominator, and you could actually use the multiple method here. The 8 is going to work. 4 would divide into 8. You could do primes. For 4, you could do 2 times 2, and for 8, you have 2 times 4, which is 2 times 2 times 2. And then for your LCD, you take the factor from the one where it occurs the most. So we're actually going to have the 8. So our LCD is 8. That means we have to work on the first fraction. Bring down what you have, and we'll put on the missing factor. So we look at the denominator. We have a 4. We'd like to get an 8. So we're missing a factor of 2. Do the same to the numerator. And this will give you an equivalent fraction with that denominator of 8 that you want. The second fraction already has the denominator we want, so we don't have to work on it. And now we have like fractions. So keep the common denominator and combine the numerators. For our next example, a combination of 3 fractions, we are going to have to find the common denominator. So for our first one, 2x, this one is already broken down. For 4x, 4 will break down to 2 times 2. And for 6, 2 times 3. And then from those, we will pick each type of factor where it occurs the most, the greatest occurrence. So for the 2's, greatest occurrence is in this middle one, 2 of those. For 3's, in the last one. And the x is the same in all, so it doesn't matter which one you take it from. So our LCD, we're going to have 2 2's, a 3, and an x. So 4 times 3 is 12x for our LCD. So we're going to work on each fraction. So we'll bring down what we have. And we're going to think of our LCD. And what's missing here is what we're going to put on. So, and kind of think in categories. So I have numbers and then I have variables. So I have a 2 and I want a 12. This one is missing a factor of 6. I already have the x. So I have 6 over 12x. Bring the next one down. This is what you have. Check your denominator. This one has a 4. We want a 12. So it's missing a factor of 3. It already has the x, so that part's okay. So we have a minus 15 over 12x. Bring the last one. Check your denominator. You have a 6x. You want a 12x. This one is missing a factor of 2. Put it on, numerator and denominator. And this will give us 14 over 12x. Now we have like fractions. Keep the denominator and combine on the numerator. You can write it all on one line if you like. So 6 minus 15 is going to give us a negative 9 plus 14. So 14 minus 9 will be 5 over 12x, and that does not reduce. For our next example, of adding rational expressions. When we look for our common denominator, we'll notice that these pieces are totally different. We're going to need them both. We can't factor that down anymore, so we have an x minus 2 from this one and an x plus 3 from this one. So we need both. So we'll bring down what we have and put on the part that's missing to get that common denominator. So this one has the x minus 2. It is missing the x plus 3. Put it on, numerator and denominator. We can work out the numerators. We don't multiply out the denominators because eventually we're just going to keep them anyway. But we will multiply out the numerators because we're going to combine those. All right, now we'll bring down the next fraction, 5 over x plus 3. Check the denominator to see what's missing. So we have the x plus 3. It needs the x minus 2. Put it on, numerator and denominator. And so we will simplify on the numerator. So we'll distribute that 5. So we'll have 5x minus 10 over x plus 3 times x minus 2. Right, now we have like fractions. We will keep the common denominator. It doesn't matter which order we choose. They're just alike. And combine the numerator. So we have 4x plus 5x is 9x, and 12 minus 10 would be a plus 2. We could also have written on one line first. To see about simplifying, you have to see if you can factor your numerator. You cannot. You're down to the first power and there is no GCF, so this is not going to reduce. For our next example, we will need to factor our denominators to make sure we can get a common denominator. So x squared minus 9 is a difference of squares, x plus 3 and x minus 3. So our type of factors we have x plus 3 and an x minus 3. From the other one we have an x minus 3. So we have to take it from the one with the most. The x plus 3, we only have one. The x minus 3 is the same amount. So we're going to need an x plus 3 and an x minus 3 for the LCD. The first fraction already has that, so we'll just rewrite it with that factor denominator. For the second fraction, we'll bring down what we have. We have the x minus 3, so this one is missing the x plus 3 on the denominator. Do the same to the numerator. And then we'll get ready to clean that up. So this will give us 3x plus 9 over this denominator. And now our rule is keep that common denominator and combine the numerators. So we have 1x plus 3 is 4x plus 9. There is no GCF and the exponent's 1, so it is not going to factor and will not reduce. For our next problem, we need to factor our first denominator to see what pieces we have. And so different signs, split the x's. For 8, how about 4 and 2 would combine to give us 2. So plus 4 minus 2, you can check, and that's correct. And so for our common denominator, The x plus 4 is the same, so we're going to need an x plus 4, and we're going to need an x minus 2. So our first fraction already has what we want. For the second fraction, I'm going to go ahead and work on it up here. And I have the x plus 4. I need the x minus 2. And I will simplify the numerator. Something to be careful about here. Your minus is going to apply to the whole thing. So if you leave it there, just be cautious and distribute in a minute, or take it with your 2, either one. So if I leave it, I will have a 2x minus 4 over this denominator, and then I will need to apply it to the whole thing. So now when I do combine, I keep my denominator. Doesn't matter about your order. And I'll combine on the numerators, but for subtraction, that's going to affect everything in the second fraction. So that'll be a minus 2x and a plus 4. So 5x minus 2x is 3x plus 4. Also, you cannot factor on this numerator, so this one is not going to reduce. One more example, and this one is where we have the opposites for the denominators. You can choose either one for your common denominator. I usually choose the one that looks in order. So my LCD is going to be x minus 6. So I'm going to work on the first fraction, bring down what you have, and here I'm actually going to multiply by a negative 1 to change this into the other form. So if I multiply by a negative 1, whatever you do to the denominator, do the same to the numerator. And we'll clean that up. So it gives me a negative 4x. And your negative 1 distributes down here. So it gives me the negative 6 plus x, which is the same as the x minus 6. The second one has the denominator I want, so I'll just bring it down. And now you can keep that common denominator and combine on the numerator. Those are not like terms, so there's nothing you can do.